toaster tends to talk to my refrigerator and, keep scrubbing the internet while we're at it. But that's me. I'm Director of Mobile Strategy at VMware. I've been there a little over a year. I spent the previous 20 years in the enterprise. I've been doing mobile for 18 years now. That's me with my daughter who, she's 3 years old. This is 2001 maybe. I'm wearing a BlackBerry shirt. I don't know if you can see the logo on there. So representing Canada for Paul here. Makes him a little happy. And Twitter, you want to talk to me, that's the place to reach me, BM Katz, easy way to do it. But what we're here to talk about is IoT and the lessons we learned from EMM, Enterprise Mobility Management. So, and I'm going to keep this as vendor neutral as I can because I'm not really, I'll mention a few of the things that we do, but that's not the point. The point is, what are the lessons that we can actually take from connecting people's phones and tablets and helping manage them and bring that to IoT? Because it's not just taking that device and connecting it to the internet. It doesn't do anything for you. It's what you do with that device, what the data is that you get from it. And the answer is not blockchain. And I promised Steve Wilson that I mentioned this, and this is Steve. Blockchain is this alligator, and everybody says blockchain is the answer to everything. We're in an identity conference, and it was nice that this morning and yesterday as well, people didn't offer blockchain as the solution. And it's not the solution to IoT either. It's a ledger. You need to know what you're doing. How do you plan for it? If you don't know what you're talking about and you have no idea what's coming, how do you plan for it? How do you, in IT, identity, in managing devices, rolling them out, in the business, plan for anything if you don't know what you're actually talking about? So we need a place to start. And the best place to start is a use case. Because if you don't have a use case, it ends up looking like this. You create your own Rube Goldberg machination where you're connecting sensors, you're doing all these pieces, and you don't know what for. And they talk different languages. There are currently 200 platforms out there. There were only 198 IoT World 3 weeks ago in Santa Clara. Both HP and, I forget, it may be Huawei, but both HP and somebody else announced 2 more platforms. And they also announced, and there's 60 different standards for communicating with these devices. So you need to come up with a plan and you need a use case because you don't know where to start. You're in trouble. 2 billion smartphones out there right now, and that's growing. Almost 500 million tablets. Think about that for a second. That's a lot, but there are 7 billion people in the world. When you look at things, and I thought Chuck did a great job talking about things, but we're not talking about just thermostats. We're not talking about our phones. We're not talking about our smart watches. We're not talking about our GPSs. We're also talking about airplane engines, toasters, Paul's toaster to be specific, washing machines. We're talking about all these different devices that when you're working on a line. So I was in the pharmaceutical industry for 12 years doing mobile engineering and server engineering. We censored every machine on our line. Look at GE. GE has sensors in everything. A typical jet engine in an hour's worth of time generates more than a terabyte of data. And that's just the data that they collect from the sensors in that engine. And they take all that data, they throw a bunch away, but they take all that data because they want to make sure you're safe when you fly. So they look at that data after every flight. They're trying to make sure that your airplane stays in the air. So when you start looking at it, home use, that's not a lot of devices. Look at the enterprise. You're talking about the industrial IoT, Internet of Things. BI, you'll notice the growth here. That government and infrastructure, those are still things. Those aren't the stuff that you carry around. Those are roadways. You look in, Finland has actually put sensors in the roadway so they know when they're about to start freezing. And they have sprayers that come up that spray the road and actually make it safer to drive in the winter. So these are roadways, these are bridges. How do we know when a bridge has a problem right now? It fails. Hopefully there's nobody on it, but that's what happens. You have to start looking at where sensors are going to be. They're going to be in everything. I gave this definition last year at a presentation here. IoT is connected sensors that provide you with data that allows you to make contextual decisions and then act. If you don't understand that definition, you don't understand IoT. Because it doesn't matter how many sensors you put out there. It doesn't matter how much data you get. If you can't act on that data, it's useless. People talk about big data all the time. But big data only makes sense when you can parse and figure out what to do with it. So IoT, if you look at that definition, comes down to three things. How do I manage things? How do I capture that data? And I apologize, this is a VMware slide, but how do we then take that and create service delivery? And it's going to be in the cloud. And the reason we say it's going to be in the cloud is because there's so many devices in so many ways, you have to figure out how to handle this and make decisions on it. And that's that service that you're actually building. This is a train in India. You know, there's probably very few people on. This is what the mobile industry looks like. When you start looking at the industrial IoT, this is what the train looks like. You can't count the number of passengers on it. It's hard to collect tickets. They're hanging all over the place. If you add a car, all those people who are standing there are getting on the next car. The longer the train is, the more people are on it, and they're everywhere. And you need a way to figure out how to manage these devices and manage a million things like you manage one thing. Because how do you manage, if these are all devices, where's Waldo in here? How do you manage Waldo? Well, one way to manage Waldo is make all the ones that are Waldo look the same and manage them similarly. How do we group people together to get all these Waldos? So one of the things that we've learned from EMM is manage millions of things like one thing. And that's what we call smart grouping. We're not the only one that does it, but what we've learned to do is how do we actually aggregate devices, whether it's by location, whether it's by attribute, whether it's by owner or identity. How do we take those pieces, put them together, and create these smart groups that we can actually manage those millions of devices, that train load of people, and say, we care about all the people who are going to Chennai versus all the people who are going to New Delhi. And I have no idea if they're on the same train line, so I'm going to apologize if I offend anybody. But smart, you know, one of the things we do in mobile, we can look at a team of people and say, everybody in this team who has an iPad, they may have an iPhone, but if they have an iPad, we're going to deploy this app. Well, you can do the same thing in industrial IoT or even regular IoT. Everybody who has this device or this sensor and is at this level and is at this location, we want them to be able to do X, or we want to pull that data. We want to make their watch face look a certain way. We want to make the screen on that machine show something. Good example, and we're going to go, I'm actually going to end on the CocaCola example. But CocaCola deploys freestyle machines all over the world. These are expensive. Two of the places they deploy them are Burger King and AMC movie theaters. That screen that you see, has everybody here used a freestyle machine? Or most of the people here? So that screen up there, if you're not at the machine, they've turned into a splash screen, just like a video game. And what they discovered last year when Jurassic World came out, AMC said, can I take that screen and put Jurassic World on it? Because I think more people come over and get more soda. And it worked. We helped them do it. But the point is, it worked. Do you think Burger King wants Jurassic World, especially if they're not the ones that got the toys that go with Jurassic World? Maybe it was McDonald's, maybe it was Wendy's, whoever it is. So they want, those machines have to be controlled differently. And that's where smart grouping comes in. And actually CocaCola does it this way. Burger King restaurants are done differently because Coca-Cola has them all in a similar console. Because Coca-Cola actually owns that data. And we'll talk a little bit more about that. But that smart grouping enables them to say, all the theaters, because they even break it down in AMC, when Jurassic World leaves the theaters, they can pull that splash screen off those devices because the attribute changed. And they don't actually have to be managing that single device to say, did I pull it off that device? Because of the location and the attribute of, did Jurassic World leave those theaters, that splash screen goes off. And they can actually push another splash screen depending upon what movie's playing there. So things. Do things have an identity? Chuck talked about it. Chuck talked about it as far as a thing has an identity based upon the person who's wearing it or the person who's using it. He was talking about thermostats, a couple other things. Makes a lot of sense. But if I have a jet, we'll go to the jet engine, or actually in the pharmaceutical industry. We actually have giant vats where we actually create, we combine all the ingredients, and they have 20, 30, 40 sensors on them. Do they have an identity? Is it the operator of that machine? Is it the machine itself? Is it where the machine's located? Is it the line that it's part of? How do we identify those things? Now, by the way, a lot of these things have no screen. The thing here, if you read the Fantastic Four, one of the issues he had was he couldn't carry identification because his suit didn't have pockets in it, and his hands couldn't reach in the pockets. How do you carry a driver's license? Say, look, I'm the thing. Nobody else looks like me. Yeah, well, in this day and age, that's not enough attestation to say that's who you are. So how do we identify things? Location's a good start, what it does, and how do we get that identity actually to that thing? And Chuck talked a lot about it. Tokens, you can't necessarily use the same thing that you do with people. Hang on, let's see. Anybody remember this screen? Windows certificates. Giving out Windows certificates. Do I have to be done early, or I have a timer here? I'm asking Paul. Am I good?
How much time does it say?
13. Just checking. You guys remember certificates. Giving out certificates used to be a pain in the butt. So what you do? You got a certificate authority. But that's not enough. This works great for people. But when you start adding devices, and we saw it actually at Sanofi, we didn't allow Android devices in. So going back to lessons from EMM that we can apply, we had people who would bring Android devices in. And by the way, they were always IT. IT were the ones who actually broke the rules and broke the model. They'd bring an Android device in, and they'd go to their computer, and they would extract a cert for the Wi-Fi that we did not give out. We specifically had a rule that said if it's an Android device, don't give it out. They would extract the cert from their computer. They do a little magic, and the funny part is it was someone from security who figured out how to do this. And they put the certificate on their Android devices. And this is 4 years ago, 3-4 years ago, when it was a little bit tougher. There was no control there. So part of one of the lessons that we learned is you actually have to be able to manage those authorities, how you give out those tokens, whether it's a cert, whether it's a token, and those have to be integrated into your management console. And when you integrate those into your management console, you can give out tokens. You can also retire tokens. What happens if a device breaks or you're getting rid of a machine? Should it keep its identity? When it moves off the line, that identity needs to change or be retired. Doing that by hand is a pain in the butt because you may have 40 sensors. A whole line may have a couple hundred sensors or a couple thousand sensors. So you actually need to integrate with those authorities to give out, whether it's a token authority, whether it's a certificate authority, and you need to use something that allows you to do that. But we mentioned that it's not just about the things, it's about the data you get from those things. And if you ignore that and you don't manage that, a way to connect to that data, bring that data in securely. We're going to talk about security in a second, but bring that data in securely. Be able to give that data off to other people. I don't care what, we mentioned 200 platforms. I don't care what platform you look at. Anybody who says that they can do it all is lying to you, including us, and we don't say we can do it all. If somebody says that to you, they're not telling you the truth. I don't care if they tell you they have a complete platform. They're partnering with somebody. And it's those partnerships and being able to take that data and hand it out that makes all the difference in the world. We're not the only ones that do it. We partner with a lot of people for analytics, whether on the phones, Criticism, who's changed their name, New Relic are two of them. There's Splunk that we partner with. How do you take that data and give it out to people and then actually allow it to come back in to take actions? Because part of IoT is being able to communicate both ways. And you have to be able to life cycle things. Things don't last forever, sensors don't last forever, sensors break. And if you're given a token out and says it's there, how do you replace that device? And how do you do it without tearing your hair out? Something we learned early on in EMM was, whenever a new phone came out, a new iPhone came out, magically people would drop their phones in the toilet or drop them from the second story, out the window. Oops, went into the river, went into the lake, I need it replaced, and they'd want the new one. We solved that quickly. We gave them the old one back, just a different one. But how do you give them the data back? How do you give them the identity? How do you give them all the pieces that they need? How do you give them that certificate? You need those pieces built into your management. If you don't plan for that, you're going to fail. Because you roll it out once, it works perfectly for a month, a day, a week, 6 months, a year. But the first time one sensor breaks, if you can't replace that sensor, replace that device, and do it easily and have it go back into that smart group, your data's flawed. You've lost everything that you've worked so hard for. And that's part of how you have to look at what you're doing. And one of the things that you learn from EMM is the cycle doesn't just stop with the identity. It's the data, it's the apps on it, it's how you're bringing that data out, how you're acting it. You have to have a way to trace that, track that, group that, so people can act on it. Security. First of all, I'm assuming everybody here is doing something with IoT. If it's anything like mobile, you don't include your security team until you've already rolled it out. They have no clue what you're doing until all of a sudden they see things pop up on Wi-Fi or some other format, could be Zigbee, whatever else, but they're tracking it. You have routers out there. All of a sudden they see all these devices pop up, go, what's that? How do I shut it down? Because I can see the traffic, I can see what's doing it, somebody driving by. So we do a tour, people walk in. So you have to figure out, how do I look at things like microsegmentation? How do I do security around my network so that if someone can break into a device, they can't talk to my whole data center, my whole cloud, they can't corrupt all the data. Do I do that when I have billions of devices? Because we saw that by 2020, 20 billion devices. How do I take those and all of a sudden say, do I do security from end to end? Or do I do different types of security, for example, to a local gateway, then to a bridge, and then to my data center? How do I secure that whole path, and do I need the same type of security the whole way? And part of that's determined by identity, what the devices are doing, how they work. Interesting that it all comes back to grouping again, because as you're putting all these sensors in a device, anybody know how many sensors are in their phone? And Andy can't answer that because he should know. Anybody have a guess? 6 or 7. Okay, 6 or 7. Anybody else? 18. 18? You're probably closest because they keep adding. But I have a slide, which I don't put in this one, that shows over 25 sensors. And that was 2 years ago.
18 is closer to 25.
But that was 2 years ago. They keep adding more. They didn't. Motion coprocessors just got there. They actually detect. That's not just the accelerometer. There are 6 different sensors right in there. They put strain gauges, temperature sensors, pressure sensors, light sensors. You put all these things, and the light sensor now actually has a second light sensor, so it can see what color of light. So, for example, you get the new iPad Pro, the 9.7. It actually changes the color of the light on the piece. Now, imagine that's a phone. Imagine putting all those sensors on a machine line. And each sensor, you can have hundreds or thousands of sensors, and all those sensors mean something. But you also have to know how to secure that data. Because, by the way, you don't want somebody hacking that GE jet engine or that Rolls-Royce jet engine, either knowing what it is or being able to act on that data to force something to happen. My guess is most of us are flying home. We all want safe flights, and that's what we usually get. But data is important, and security is more important. So you need to look at microsegmentation. You need to look at how you actually secure, and identity becomes a big deal. How do we know that the data we're getting is from the sensor that we want it to be from? So I want to talk a little bit about the Coke issue so I can bring some of this back together. Coke had a problem. that they identified in early 2000s. Their problem was for every restaurant, every store that had the Coke machines in them, Burger King, McDonald's, movie theaters, anywhere you went, quality sucked. You go, you get a soda, you went to 7-Eleven, you went to Wawa, whatever it is, Tim Hortons. You go, you get a soda. Sometimes all you got was syrup. Other times all you got was carbonated water. Sometimes you got something that they put the wrong syrup in the wrong thing. So Coke had a quality issue. It was 2000, they were still using devices that were actually older than from 1974. The only change that had happened was that they'd actually put more choices. So you, instead of, it used to be 4, then 6, then 8, then 12. And Coke looked at it and said, how do I modernize my machines so I have fewer quality issues and I can actually reverse the trend? Because the trend that they had was that same store sales were going down, people weren't buying soda, people weren't buying drinks. So they said, I want to do a couple things. I want consistent taste and quality. I want to improve the variety. I want more than 8 choices for people when they go to a restaurant. I want it networked, and we'll explain why in a second. I want it engaging. That's why the screen's on front. It's not a simple button. You can actually do stuff when you have that screen. So Coke built the Freestyle, and they built it based upon medical technology. So there's a micro pump in there. They went from the boxes with the giant bags and the big scuba regulator type thing that they had to hook up, and somebody would roll out of the back room, and they would keep a whole room of just these syrups. They went from that to essentially printer cartridges with ultra concentrated syrup, and you just take the printer cartridge in, take the one out, put the new one in, and that same machine you saw, that same vending machine, all these different choices. Imagine you can go to a restaurant and you don't want caffeine, you don't have one choice now. You actually want diet, you have a lot more choices. You want water, because by the way, Coca-Cola makes water. Well, distributes water. I shouldn't say they make water, although they make flavored water. Here's what they saw, and this was just first year. They actually had people who would refuse to go to certain movie theaters based upon the fact they didn't have a Freestyle in the theater. That's kind of amazing. I actually have a friend whose kids will not let him go to a non-AMC theater without a Coke Freestyle in it. But why did they want to connect it to a network? Consumption information. Coca-Cola now knows, and by the way, Coca-Cola knows, not the restaurant. Coca-Cola knows exactly how many times that machine was used, what flavors were used, how you used it. And by the way, this is where Coke Cherry Vanilla came from. What they saw was people would put their cup in, they'd do Coke Cherry, and without removing it, very quickly changed to Coke Vanilla. What did they do? They bottled it. People bought the bottles because they were making it, and they could look at that consumption data and say, this is what's happening. But they took replenishment out of the hands of the restaurateur or wherever the Freestyle was. So that room became a shelf. They do just-in-time delivering. They load these things up on FedEx trucks, on other trucks. They show up right when you need it before you knew that there was a problem. They also get diagnostic information. So they know the temperature inside and outside. So they know what people consume on a hot day versus a cold day, but they also know when the machine's going to break. Remember I said this is medical pump technology? So they're putting microbursts of syrup in. They're actually taking feedback to know when things are breaking. They will send a technician out to the site to fix a machine before it's broken and before the vendor who owns that machine knows there's an issue. Somebody shows up. That's, by the way, why they pay so much for this. Because this machine's not cheap. This is quite expensive. Although they do make a tabletop version now. Consumer engagement. You can make your own recipe. So there's an app. I have it on my phone. You can create your recipe. I know Paul has one because his toaster told me. So it's called Paul's Kick-Ass Pop, because they don't really call it pop up there supposedly. But I won't tell you what's in it. It's a little gross, but it's what he likes. He can share that with all his friends. And if Coke sees that and sees a lot of people doing it, they can either make a special bottle for that area of Ottawa that he's in, or if that starts spreading, they can use that data to sell more soda. That's the app. It's a QR code. You show it to the machine. But remember I talked about platforms before? And this is why I want to show this slide real quick. There are all these different layers. All these different companies are part of what makes the Coke Freestyle work. This is a whole platform. How do you provision, command, and control? You know what they used to do to upgrade a machine? They used to walk with a USB stick. And it would take, you'd have to insert the USB stick. It would take some time. They'd have to take the machine down, open it up, put the stick in, do the upgrade. Nowadays, they do it all over the air. These machines communicate back every single night. But where's this data go? So AirWatch helps grab that data. But AirWatch feeds that data to Splunk, Salesforce, SAP. All this data goes back and forth. Coke can then act on this to know when something breaks, when they need more syrup, when, by the way, one of the things Coke does is people aren't using a syrup, they'll take that syrup out and send that vendor, whoever's got that Coke Freestyle, a different flavor because it's not selling there. They also can figure out regional differences. So they know if there's a problem in a region. And they'll say, you know what, this region loves this flavor. Maybe I should put more of those in the bottles in the stores around there. I mentioned standards before. This is happening. I guarantee you there's a new IoT conference coming up in the next 3 weeks. There will be another announcement of another platform and another standard for how they communicate. You need to work with people who can do and talk all these standards and are willing to play. I mentioned Paul's toaster. If you ever wonder how Paul actually tweets as much as he does in the morning, it's a thing. And his toaster talks to his fridge, sends all these. Thankfully, they took he covered up the camera. We really don't want to see him in the morning. Questions? I think I hit 25 minutes.
Awesome, awesome timing. Keanu Reeves, Pop, and there was another Canadiana reference. That was wonderful. What was Timmy's? Did you refer to
Yes,
Timmy's?
I referred to Timmy's.
I think we do have time for questions. Anybody? So, so mobility is characterized, at least currently, by two OSs with different security models, different theories about how to secure those devices. Do you think that'll happen in IoT?
We're already seeing some of it. You're seeing a lot of sensors are running QNX. You're seeing, especially when you're talking cars and the like. BlackBerry, who owns QNX, has actually released APIs. QNX is what runs the Coke machines. So Coke machines are running off QNX. That's how it's being managed, the remoting, everything else. You see Google talking about Brillo. You see a few. I think you're going to see a lot of those standards come down because it's just people need to talk to each other. And so it's going to make it easier to manage.
Great. Thanks again, Brian. Any questions before we change over?
Yep, right there.
Question regarding the identity. You mentioned there's so many sensors in one device, right? So what should be the real identity for that device? This is the question you asked. I'm not sure what's your answer.
So I'll riff a little bit off of what Chuck said in the previous session. I don't think that it is the user, because it's not when you're talking about a device, the user is the actual device itself. And so I think that what you're going to see with identity, it's actually going to be associated with the machine it's on and what its function is and its location. You're going to have a bunch of attributes that have to be part of that so that when that actually goes off and there's a problem on that machine, they can actually look at that data, identify where it is, feed it to whoever's handling it, and they can get there, whether it's fixing the machine or fixing the sensor itself. And that'll become part of how you give out identity. But I think it's actually going to belong to the machine that it's on or the device it's with versus the person who's managing it, because that will change in industrial IoT. Did I answer the question? Mostly? I can answer more later, and we have some great people here from VMware.
Thank
yes.
you very much.
You have one more if it's up to you.
So how do you address the machine to machine aspect or sensor to sensor aspect? Sometimes information
question is, how do you address machine-to-machine, sensor-to-sensor?
We were running out of time, so I was going a little bit quicker, but part of what happens is you can't have every sensor talk to your central brain, wherever that is. So you're going to actually have gateways that sit very close to these machines that are going to let machines talk to machines themselves. We announced an open source piece called Leota, which is a little IoT agent that can sit on a gateway and help influence that and help watch the traffic, but still let the traffic go locally before it comes up. So you're going to see sort of a mesh network, I think, where machines will talk to machines, but then the gateways can aggregate the important stuff and bring it up, because not everything's important when they're talking to each other.
What was the agent called again?
Leota. So if you look at Liota, there was a press release on it, I think last Thursday or Friday. I was on vacation, so I don't know which day it was, but we did announce that, and it's actually pretty cool. And it is open source.
Thanks, Brian.